In today's note, we are going to look at factoring complex trinomials. So a complex trinomial is whenever a trinomial has a value of a that does not equal 1. So remember, our general form for our trinomials is ax squared plus bx plus c. We've looked at simple trinomials where we haven't had the a value, but a complex trinomial is when we have an a value and it doesn't equal 1. So the first thing we should be doing is we should check to see if it can be common factored. And if it can be common factored and that a value taken out or factored out so that it becomes 1, it's a lot easier to work with simple trinomials, just because our numbers are going to end up being smaller in the end. So in general though, a trinomial that's in the form ax squared plus bx plus c, where a does not equal 1, is known as a complex trinomial. And how we factor a complex trinomial is similar to how we factor regular or simple trinomials, but there's one extra step, or there's a couple extra steps actually, but it is in the same similar form. And the method that we use to solve or factor these complex trinomials is called decomposition. And what we need to do is we still need to find two numbers. So similar to the last type, we have to find two numbers that multiply to give us a times c. So whereas before it was just c, and add to give us b, which is still the same. So still add to give us that middle number. Then what we have to do is we have to split our b value up into those two numbers and then factor by grouping. So again, it's similar to simple trinomials, and it does involve or require factoring by grouping. So let's look through the first example. So I want to factor 3x squared plus 17x plus 20. So right off the bat, I can see that it's a complex trinomial because of this a value. It doesn't equal 1. So I have to factor it through this decomposition method. So in order to do that, I need to find two values or two numbers that multiply to give me a times c, or 3 times 20, which is 60, and they have to still add to give me that middle number. So again, I'm looking for two factors or two numbers that multiply to give me a times c, or 3 times 20, or 60, and they have to add to give me 17. So in this case, this is going to be a little bit harder because we have to think of some larger numbers here. But what we should find is that our two numbers that work are 12 and 5. And again, the reason for this is because 12 times 5 equals 60. 12 plus 5 equals 17. So those two numbers work. Now that I have my two numbers, this is where it differs again, is I'm going to split up my middle number. So 3x squared, I'm going to split up this 17x into 12x and 5x. And the 20 is still going to remain there. So this 17x has been split up or decomposed into two different numbers, right? And this still works because basically I'm just breaking it down into two numbers. I could collect like terms and get it back up to 17, so it's okay to do this. Now what I need to do is factor by grouping. So factor by grouping is where I'm going to look at my two terms or my two sets here and see, is there a common factor that I can, or is there something I can factor out of those two terms? In the first set or first pair, I can see that there is a 3 common and an x common. So I'm going to factor out 3x and be left with x plus 4. Now the goal is, because we're factoring by grouping, we want to factor something out of this second pair that also leaves me with x plus 4. And this is more important to think about when we have negative numbers, but when we have all positive numbers, you're basically trying to factor it as much as possible, and it should work out. So if I look at this second pair, 5x plus 20, I can see, or I should be able to see, that the only factor that I can take out is a factor of 5, which leaves me with x plus 4. Now I have a common factor, or I can factor by grouping, because I have a common factor of this group of x plus 4, or this entire bracket. So I'm going to take that out. X plus 4 is going to come out, and my next bracket is going to contain all that remains. So in this case, the 3x plus 5. And this bottom line, x plus 4 in brackets times 3x plus 5, is my factored form. And if you wanted to check, you could expand this, use your multiplying or expanding binomials FOIL method, and you should get back up to your main answer. So this is how you factor complex trinomials. Let's try to go through another example. So I have 3x squared minus 10x plus 8, and I'm looking for two numbers that multiply to give me the product of 3 times 8, which is 24, and they add to give me negative 10. So again, it's a complex trinomial. That's why we're trying to find two numbers that multiply to give us a times c, which is a and c right there. And add to give us b, that middle value. So the factors that I'm looking for, you can use the same type of patterns that we looked at in simple trinomials. Because they multiply, or the product is a positive number, and they add to a negative, that means my two numbers have to be negative. So in this case, the two numbers that I should find are negative 6 and negative 4, because negative 6 times negative 4 equals 24, and negative 6 plus negative 4 equals negative 10. So now that I have those two numbers, I can decompose this middle term, or this b term, into my two numbers. So minus 6x and minus 4x. And now my goal is to factor by grouping these first two parts. So if I look at the first pair, what is common between these? I should see that I have a 3x again that's common. So I'm going to factor out 3x, be left with x minus 2. And if I look at the next one, minus is there, I'm going to factor out a 4. I have x plus 2. So this doesn't work, right? So looking at this, it doesn't work because my brackets aren't the same. So what we have to do actually is go back, and we have to include that negative in front. So if I want to factor something out, in this case, I'm going to factor a negative 4 out. So we do have to include the sign. And when I factor a negative 4 out, I'm left with x minus 2. And now I have the same bracket. So that means I'm going to factor by grouping. So x minus 2 is going to be my one bracket, and my second bracket is going to be all the remainders. So the 3x and minus 4 are going to be my second bracket. And that's the factored form. Again, moving on to look at another example. Find two numbers that multiply to give, in this case, 6 times 6, or a times c, which equals 36, but add to give negative 13, or my b value. So my two factors, again, because they add to a negative number but multiply to a positive, I should be looking for two negative numbers. In this case, negative 9 and negative 4 are my factors, because negative 9 times negative 4 equals 36, and negative 9 plus negative 4 equals negative 13. Now that I have my two numbers, I can break up or decompose this middle term, or this b term, into those two numbers. So one is going to be minus 9x and minus 4x. The 6x squared just remains the same, and the plus 6 remains the same in the same positions as well. So all we're doing is just making it slightly bigger. Now I'm going to factor by grouping by looking at these two sets. Again, I'm going to include that negative on this 4x squared, or 4x. So I'm including the signs in front. If I look at the first pair, I should see that I have a common factor of 3x, which leaves me with 2x minus 3. And if I look at the second pair, again, I look for a common factor. I should see that I have a common factor of, in this case, it will be negative 2. And the reason I'm common factoring out a negative 2 is because in order to get the same bracket of 2x minus 3, I need to make sure I common factor out the negative. If I don't, say I was to common factor out a positive 2, that would leave me with negative 2x plus 3, and these two brackets don't match up, so I couldn't factor by grouping any further. So we do want to make sure that we try to factor by grouping in order to make sure that we have a common bracket. So that's why I have to common factor out a negative 2 to leave me with 2x minus 3. And if you try to common factor and you use the wrong sign, as long as you recognize that your numbers are right, it's just the signs that are different, you can just switch the signs. So make that a negative and change the ones in the bracket. Because when you factor out a negative 1 or the negative sign, that's all that's changing, is just the signs. So now I can look at my factor by grouping. So I can see the bracket of 2x minus 3 is common, so I'm going to factor that out. And then all that remains for my next bracket is 3x minus 2, and that is my factored form of this complex trinomial. Again, so we're just going to go through more examples just to kind of get used to this process. Again, there's not a real trick to figuring out what your two factors are. There are some hints of kind of what we talked about with the simple trinomials, at least in terms of signs. But in terms of finding those factors, it's more or less just becoming comfortable and practicing this a lot. So 12x squared minus 25x plus 12, we want to factor this. So I need to find two numbers that multiply to give 12 times 12, or a times c, which equals 144. And they have to add to give negative 25. So this one becomes a little bit trickier because we are dealing with larger numbers. So if I want to find my factors, again, because the product is positive and they add to a negative, I should have two negative numbers. In this case, we have negative 9 and negative 16. So again, it may just be some trial and error at first, but hopefully you do get to those two factors. And again, negative 9 times negative 16 equals 144. Negative 9 plus negative 16 equals negative 25. So those two numbers work. Again, with those two numbers now, I can decompose this middle term into those two numbers, so minus 9x and minus 16x. The a and c do stay the same, they just get carried down. And now I'm going to factor by grouping. So if I look at the first term, I see, again, I have a 3x. It seems to be a pattern going on here. I have a 3x that I can factor out and be left with 4x minus 3. In my second bracket, I'm going to factor out a negative 4. 4 is common, but I can tell that I want to have the second bracket or the second term negative, so I want to factor out the negative sign to change these. So if I factor out the negative 4, I'm left with 4x minus 3. I should see that my brackets here are the same or common between these two terms, so I can factor that out. And so again, factoring by grouping. And my second bracket is just going to be the remainder of what's left over. So the 3x minus 4. And there we have our factored form. In the next example, 4m squared minus 22m plus 10, again, I can go through and try to find my multipliers or my common factors. But there is something that I can do first. Right? And the first step, what you always want to look for, and I know we haven't mentioned it in the last couple ones, is we want to common factor. So you always want to common factor first. So you should be looking to common factor first always. In the last examples, there isn't anything that we could have common factored, so we haven't missed anything. But in this example here, hopefully we can see that all the numbers in front, or all the numbers that we have, are even numbers, so we should be able to at least common factor out a 2. So if I'm going to take a factor of 2 out, everything that remains is 2m squared minus 11m plus 5. Now, it would have been nice if common factoring took out the complex trinomial, but unfortunately we still have the 2 in front of the m squared, so our a value is not 1, so it's still complex. However, we are dealing with some smaller numbers, so that at least will hopefully make it easier to find our factors. So we're looking for two numbers now, and again, we're just going to focus inside the bracket. So we're looking for two numbers that multiply to give the product of 2 times 5, which is 10, and add to give negative 11. So the two numbers that we should find are negative 10 and negative 1, because negative 10 times negative 1 is positive 10. Negative 10 plus negative 1 equals negative 11. So those two numbers work. So now what I'm going to do, I'm still carrying that 2 on the outside. This negative 11m is going to decompose. So 2m squared minus 10m minus 1m plus 5. And now I'm going to factor by grouping this inside, these two terms on the inside. The 2 still stays on the outside because we did factor it already. We're going to end up using. So if I look at the first pair, I should see that I have a common factor of 2m. So I can factor out m minus 5. In my second pair, I'm going to factor out a negative 1 and be left again with m minus 5. And now I should see that inside this bracket I have a common bracket, which I can factor out. So I'm going to have m minus 5 as my one bracket, and my second bracket 2m minus 1, or essentially all the leftovers. And that is my factored form. And I can see that I've common factored it first, so that's why the 2 is out front. Again, if you're ever unsure, you can always expand this, and it should lead you back up to the first answer, or the first expression that we started with. In our final example, again, same idea, same steps. Looking at this though, before we even start getting into factoring a complex trinomial, we should see that we can factor our common factor. Oops. So again, always look to common factor first. You may not be able to, which is fine, but if you can, it is helpful to, because then at least you start with, or you deal with smaller numbers. And in some cases, you may be able to turn it into a simple trinomial, which means it's a little bit easier. So looking at this, I can see that there is no variable that's common. However, there is a factor of 4 that can be divisible into all of these numbers. So my common factor, or my greatest common factor, is going to be 4. So I'm going to take the 4 out. All that remains is 2x squared minus 5x minus 3. Unfortunately, inside that bracket, it's still a complex trinomial, so I'm still going to have to factor a complex trinomial, which is fine, because now I'm dealing with smaller numbers and I've gone through plenty of examples before, so I am getting the hang of it. So I have to find two numbers that multiply to give me 2 times negative 3, which is negative 6, and add to give me negative 5. So this one's a little different because my sum is negative and the product is negative over here of what we're trying to find. So that means my factors, one has to be positive, one has to be negative, and the larger number has to be negative. So again, it doesn't really help me find the numbers, but it does help me play around with the numbers that I know, because really the only numbers that multiply to give me 6 are 6 and 1 and 3 and 2. If I've already said that the larger number has to be negative and the other one has to be positive, well, negative 3 and positive 2 don't work to give me negative 5, so that only leaves me with one option, negative 6 and positive 1. And when I do go through that, I find that it does work and gives me my correct factors with the correct signs. So it does kind of help you in a way, especially if you have a limited amount of factors. So what I'm going to do now is factor by decomposition, or use decomposition to break this up. So 2x squared, then minus 5x now becomes minus 6x plus 1x. The minus 3 is still there. And now I'm going to factor by grouping. The 4 still remains on the outside. If I look at my first pair, 2x squared minus 6x, there's a common factor of 2x here. So I get x minus 3. And if I look at my second term, there's not really anything I can factor out. I could say I'm going to factor out a 1. So I can just do x minus 3. So there's nothing really I'm going to factor out there. Now I should see that I do have a common bracket here, which I can factor out. Oops. So x minus 3 is the factor that comes out. And my second bracket is going to be everything that remains. In this case, it's 2x. And although I don't see anything here, there is still going to be a plus 1, right? Because remember, there is that imaginary or invisible 1 in front. So my second bracket is going to be 2x plus 1. And now I've factored it completely. So again, while it is a little bit trickier because we are dealing with some larger numbers and we have a few more steps, I didn't show this breakdown. We can still factor a complex trinomial in a similar style to a simple trinomial, although we are going to involve decomposition and factoring by grouping. But again, Just make sure you go back, follow the steps, practice and practice and practice to make sure that you're comfortable with the steps and you start to become more familiar with the different factors of some of these numbers. Because again, that's what the factors you become comfortable with.